so I can find you. Oh, there you are. Coming. That's all of you, whenever you're ready.
Right. Hi, everyone. Good afternoon. We are Team AI Playtesting. AI Playtesting is a student-pitch project that is developing a reinforcement learning agent to playtest a turn-based combat card game and help designers with game balancing. Our faculty instructors are Mike and Scott. This is our team. First, I am going to talk about our motivation behind this project. Our motivation is mainly divided into two parts. In the technical space, we are focusing on applying reinforcement learning technique in the process of game development. On the other hand, in the design space, we are focusing on making some progress and innovation on the process of playtest. So talking about the technical space, AI is not widely used in the game development. And we believe that AI technology is the future technology. Since each game has its unique game mechanics, it's very hard to develop an AI agent that could apply to multiple games. So in our project, we are trying to deliver a technical report to share our experience on making the AI so other future game developers can look at our developing process and make their own AI. On the other hand, the design space, we know that the game balancing is very hard to do. Developers usually need thousands of playtests to collect enough data for them to do the balancing. And these data also may be not accurate enough because playtesters might have player skill difference that would add some noise into the data. However, our AI playtesting agent provide a much cheaper solution on that. Designers could do the playtest just within one click, and the AI will run the game for over 10,000 times and generate precise playtest data for the designers without worry about the player skill difference. A quick introduction to the game we've implemented for our AI, which is Slay the Spire. This game is a player versus environment PvE combat-based card game. The player's goal is to reduce boss HP and win the combat. The way to execute attack and defend actions are by playing cards. The player could also apply special buffs to himself or to the boss to deal higher damage or receive lower damage from the boss. Next, I will hand to Danny to talk more about our demo.
So now I'll demo our app first. So the workflow of our prototype contains 3 steps: design, training, and play testing. In the design step, you can build your decks by adding or deleting cards. For example, here I added Shrug It Off and Strike Plus to my deck. I can remove them as well. If you want to play the game by yourself, just click on the play button. It's opening a Unity project where you can do human play testing by yourself. There is an advanced mode where you can use your own imaginations to create your own cards. To create a card, specify name, energy cost, description, and other input fields. You can also upload an image to best represent your cards. Let's say I want my damage to be 30, and then I save it. So I can go back to the main page to add the Apple card that I have just created into my deck. So after designing your game, let's move forward to the training step. Here, you will trigger a reinforcement learning AI agent to learn strategies to win the game. Through iterations, AI keeps learning as the training goes on. As you can see on the training details, here is a win rate graph indicating the training progress. After the AI is trained, it contains knowledge to play cards well. AI will playtest the deck many times and generate statistics for you, like the win rate, game length, card analysis, and card relationships. Hopefully, you will get some insights and then go back to the design step to repeat the cycle by changing the decks or game settings. So after the playtesting process is done, we can view the result. The winning rate of this particular deck is around 100%, and the ending margin of the boss is lower than the player, which means on average, the player wins games against the boss. About the card analysis, we can see a card called Flex Plus plays at the early stage of a turn on average. That is quite true in the State Spire game. And then we can see the card relationships here. Yeah, so as you can see here, the AI plays Flex Plus as its first card, Thunderclap as second, and then Heavy Blade Plus as its third card. That is a good sequence, very powerful, that can deal a lot of damage to the boss. And AI successfully identifies this sequence, which is very good. Also, there is a heat map displaying pair relationships. The redder the grid is, the more frequent this pair occurs. And also we have anomalies, so more data displayed. So this is the demo of our app. So next is about the documentation. So here is a link for our documentation for everything that we did in the project, segregated into various topics. We also put it in the chat for easier reference. So for the docs, so you can see here intro videos, app instructions, progress of the AI, and we also have game dev along with AI with various topics. We also have design and blog post into our documentations. So next, Ron will talk about the progress of our AI.
Thank you, Danny. So I'll talk about the progress of our AI throughout this semester. The graph that you see here is the win rate that our AI got on a standard deck from phase 1, phase 2, phase 3. So you see it moves from 5% to 55% to 85%. I'll talk more about what each of these phases are. For the first phase was experimentation. Here we tested and tried a lot of different reinforcement learning algorithms, but we only got a modest win rate of about 1 to 5%. This was because we were making a lot of mistakes. And this went from week 2 to week 5. The next stage was the reward shaping stage, where we basically had a conditional statement that attributed a unique reward to each card that was played. And we were able to achieve a breakthrough in improving the win rate to 55%. And this went on from week 6 to week 7. The last phase was generalization. Here we did not want to stay with the conditional statement because that required a lot of work. And the only thing that the AI looked in this phase was whether a card can lead to victories more than other cards or not. And this led us to a win rate of 85%. And this went on from week 8 to week 12. So what was the motivation for generalization? First of all, with generalization, it can support seamless addition of new cards and new mechanics. We don't need to rewrite any of the AI code, even if we add new cards and new game mechanics. And the second thing is that it is easier to apply to other games as well, other card or strategy games. Now, Sichi will talk about game development using AI, with AI.
Okay, thanks, Ram. I will talk about the game development with AI, especially the difference compared to the traditional game. So one big difference is we have 3 versions of game. We not only have a game for player, but also have a game for AI. In this game, we get rid of graphics in order to speed up the training. And we also have another game for the playtest. But because of the frequent iteration, we cannot afford to maintain 3 games. So instead, we combine 3 versions into 1 version, which can work in different situations. So next is another big difference is we usually use some game engine like Unity to develop our game, but our project goes beyond the game engine. Game engine is only part of our architecture. So our architecture have a backend and front end. In the backend, we implement our gameplay logic in Python, and we have a database to manage the game data, and we have our AI as another subsystem. And these are all core functions of our app. And we also have a front end present this result to the user. So in the front end, we use Unity to render the graphic interface of the game itself. We use Electron to build an app for designer, just like what we showed in demo. It is the glue of all other parts. And for data visualization, we use D3.js to easily visualize the data from thousands of games. So next is the feedback. These are 2 most frequent feedbacks in the soft. So one is what insights AI can provide. So we use our app trying to find something can surprise us. And my teammate will have more story about this. And second is we need to reach out the developer of this game, the Slate Spire. So the next is we reached out the Macrate. They are the developer of this game, and we had a conversation with Anthony. He's the co-founder of the Macrate and also the designer of the Slate Spire. So from the feedback, we learned some facts that support our assumptions. So first is big data is helpful. They invite us into their big data analysis and show the result of millions of games. And second, win rate is important. They give us a number that they want to ensure the win rate is lower than 10%. So player will keep coming back in order to master the game. And third is this loop of playtest and tuning is very frequent. So these three assumptions is what we have at the beginning. And they are also the reason why our method is to generate a lot of data and try to predict the win rate and also give feedback to the designer. And however, there are also, next, there are also some limitations in this method. They are more interested in some subjective feedback. Instead of balance, they want to know if players love this card. In other words, they want to find those data cards, which nobody will use it. Another is the contextual information behind the win rate also matters. They shared us some example of their GDC talk to show that sometimes the win rate is not the only story. And next, Ram will share more story of our project.
Thank you, CG. So as CG just mentioned, because of the feedback that we got from softs, we invested a lot of time in making a concentrated effort into testing a lot of decks and finding some unique stories that we can say. So I'll present two stories to you. The first one is a story about a powerful card, and the second one is a story about how the AI learns. So the first one applies to game design, and the second one applies to the technical space. So for the story about a powerful card, we had this deck, which was one of the decks that we tested. And our objective was to add a single card to this deck and improve the win rate for by more than 50%. The win rate that this deck currently had was 5%. But we added a card called Bludgeon to this deck, and that gave us a win rate of 85%. Now, we already knew that Bludgeon was a very strong card, but in this situation, the impact that it has is drastic and quite unexpected. The second story is about the AI's behavior. One of the suggestions from Mo and Chris was to do this experiment where we start with a boss HP and we increase that boss HP and see how the AI's win rate falls with the increase in the starting boss HP. So you can see that when the boss HP is below 200 at the start, the AI can win almost 100% of the times. But when we increase it to 300 and more, like by 350, it has fallen to almost 0%. Thanks. So there are some unique, there's some comparison to be made in the way the AI plays, the strategies that it develops when the boss HP is 240 versus when the boss HP is 300. When we look at the card pair data, the heat map, we see that the hotspots on this heat map are almost the same. So the card pair data is the same between starting boss HP 240 and starting boss HP 300. But it gets more interesting when we come to card triples. In card triples, we find that this is the most popular 3-card combo played when the boss starting HP is 240. It is played 280 times. This is a good combination, but it is not the best combination in this deck. But what happens at starting HP 300, we find that there's a different combination, and this is the best combination in the deck. Not only that, this combination is played 420 times, which is significantly more than the previous one. And this means that the AI has learned not only the strongest combination, but it is also playing it more frequently. So this brings us to areas of improvement for the AI. The first thing that we can do from this story is that we can train the AI in a higher adversity setting because this enables the AI to learn better strategies. The second thing we can do is improve the win rate and performance by employing other reinforcement learning algorithms that we did not get a chance to. And the third one is that we can reward the AI for faster wins and slower losses, again, something that we did not get a chance to do. So in summary, we are AI playtesting. We started out with the vision to integrate machine learning into game development, and we wanted to make a tool for game designers that can help with game balance. What we achieved was a polished prototype with the workflow of design, train, and playtest. And we have a very detailed documentation that captures everything that we did throughout the semester, all the different techniques that we tried, how those fared for us, and what we have at the end. Thank you, and we are now open for questions.
All right, great job, team. Congratulations. Yes. So I think Mo already has a question. Anybody else just go in the chat? They can help facilitate.
Yeah, you were able to design a card that took your win rate from 5% to 85%. But based on the interview with the co-founder, 10% is really what they're targeting. Were you able to design a card that hit that threshold?
Yeah, so
I will take this. Sorry. First is we don't design this card. All the cards in our demo is from the original game. And second, talk about that 10% rate. This is also a fact that surprised us. So, and this only improve our tool is more useful because it's very easy to create a very easy deck with 100% win rate. But if you want to create a hard win rate, let's say 20% or 30%, this is a situation the designer don't know the real number. So in this case, we need a tool like this. If you don't have a lot of players, we need a tool like this to tell you it's the 10% or 20%.
Okay, so let me change my question then, if I might. What was the best card you designed and why? I assume you designed several cards and introduced them into the system, no?
So the question is, what the best card we design? So we do try a lot of design a lot of cards in our, but the problem is we don't know what mean to this best card, because in our interview with the co-founder, sometimes they think balance is not enough. Sometimes the player like this card, or this card is not strong but very fun to play. So there are a lot of combinations. So there are a lot of way to see.
So I mean, your favorite card. What was your favorite card that you designed?
Actually, the Apple card that Danny showed is pretty interesting.
Yeah. Actually, like I think one interesting card that we designed is like Apple card, but it can like have some buffs like vulnerable and weaken at the same time, and also it can deal some damage so that the effect of buff can like stay for another turn for the next round. So it's like a combination of the existing cards in the status bar, and also we add some elements inside from the newer cards. So the combination is interesting, and see our like Apple cards or Alice card to like be in the cards combos.
There's also a quick correction that I would like to make here. When Anthony was talking about the win rate being 10%, that was the win rate of the entire game. What we have implemented is just a single boss fight. So from his perspective, the win rate includes fighting a lot of minions and then 3 bosses and reaching the end. So that should be 10%, not like just a single boss fight.
Ricardo, you got a question?
Yes. So were you able to give your AI different personalities or different play styles, I should say? So like some players of games like this are really defensive. Other players tend to be really aggressive. Some people look for broken combinations and like to play dirty. Were you able to tweak the AI to account for that and see how that affected the win rate? Or is that beyond the scope of your project?
Well, I would say that because this game is player versus enemy, it is a PvE boss fight card game. Like the objective of the game is to find broken strategies, because nobody, like people are not going to get upset if they find a broken strategy. It's just something that they will like. So the entire point of doing AI playtesting is that we want to identify the most dominant strategies. Yeah.
Yeah, I would follow up. So one thing we try is in our data visualization is we not only show a simple win rate, but we also show a lot of details. So these details is just we try to tell you more about the strategy. So we want the design itself to look at this details. So okay, there might some like dirty strategy here, but we need to admit that that part is not perfect as we thought, but yeah, we have more confidence on the win rate, but to find some interesting source strategy, this is also one proper challenges we face. Yeah.
All right, thanks team. Congratulations. Good job on your final presentation. So if you all can turn your cameras and mute yourself, and I will, and if our next Team Interactive Academy can turn the cameras on, I will find you and spotlight you for everyone. And we have everyone. Whenever you're ready.
All right. Hello, we're Team Interactive Academy, and this is our final presentation. This is our team. Our advisors are Shirley and Mo, and our client is the Inanimate Dallas Research Group. Our metrics matrix are client requirements, innovation, and gameplay/interactivity. Interactive Academy uses kinesthetic learning and new media storytelling techniques pioneered by Inanimate Dallas to create an experience on WebGL aimed at sparking STEAM interest in middle school students by way of game development subjects. This is especially relevant given the current world we live in, with students and teachers forced to adapt to online learning. This combination of techniques in a remote learning prototype aims to hook students' attention and keeping their interest in the content. So, what is Inanimate Dallas? It has been a long-standing series of interactive digital novellas. This series harnesses its text, visuals, and sounds. It chronicles the experiences of aspiring game designer Alice as she travels around the world with her parents. She incorporates tech and her design aspirations by using her backseat player throughout the series, creating short animations and games. Inanimate Dallas' world has a tendency to be dark, scary, and confusing to her. However, her imaginary friend Brad, who seemingly lives in the player, is always there to help her out of her predicaments. Our project serves as a potential side chapter to the series by drawing upon Alice's experiences from past episodes and echoing the general tone of the series thus far. Research has shown that kids often don't get interested in STEAM subjects because they're complex and dense. In addition, kids are exposed to more and more media, and vying for that attention is a challenge. By tapping into gamified learning, STEAM concepts can be explored via the game development process, giving students opportunity to participate in these subjects in a tactile way. Our client tasked us with weaving the RICS framework, which stands for Read, Imagine, Create, and Share, into our experience. As a result, we decided to spark student interest in STEAM through game development concepts. Here's our demo video.
Our experience starts as other episodes in the series do, with an introduction from Alice. We learn that Alice has received a new backseat player and is going to transfer her data over. However, as the transfer occurs, something goes wrong. Alice immediately checks on Brad, who has been a digital companion of hers throughout the Inanimate Alice series, only to find that the data transfer corrupted him as well. Now, Alice dives into the digital world of her backseat player in search of Brad. In this chapter, players search the room for objects necessary to solve puzzles on the room's computer. Code blocks are used to highlight programming logic, while mind fragments harken back to Alice's experiences in past episodes. Programming puzzles require the correct placement of code blocks to fill out the logic. Here, Alice is tasked with filling in the details for a recovery tool to scan through corrupted files. Solving this puzzle recovers Brad's own memory and gives Alice and the player the ability to chat with him to learn more about what occurred. Chapter 2 greets us with a barren, textureless landscape. We learn that the data transfer affected this area as well. In order to make this area whole again, Alice needs to apply textures to these digital objects. When Alice enters the gallery after applying her first texture, the world responds to her contribution and unlocks a new mode for creativity. The texture editor not only allows for players to change the colors of any texture, but highlights hex codes as a way to connect how art and technology can be intertwined. From here, the player is free to customize the landscape as they see fit, thereby breathing new life into the area. Players are then given the functionality to save their creations to their computer.
Before halves, we finished building chapters 0 and 1 and conducted some playtests. Now I'll hand it over to Lawrence, who will talk about our progress after halves.
Thanks, Karen. For Playtest Day, our major takeaway was that we can improve instruction and guidance within our experience. We also received positive feedback and saw that students appear to be more engaged with the content due to the interactivity and story, while the perception of programming as a daunting subject decreased. With our Playtest Day data and feedback, we continued iterating on chapters 0 and 1. First, we increased visual polish. Before, some players had difficulty placing code blocks where they wanted. To improve usability, blue highlights now show where said code blocks will be placed. Visual effects were also added to amplify story moments, such as using the glitch effect to exemplify corruption and using particle effects to better sell the data transfer. We further applied more educational tactics to chapter 1. After reading some papers, we learned about the concept of scaffolding. In short, when scaffolding hints for children, each subsequent hint should be more detailed than the last. We implemented this method in the code block puzzles by having 3 hint states: no hints, normal hints, and highlighted hints to punctuate the solution. With this methodology, students are allowed the freedom to experiment and learn at their own pace while having help if need be. With chapter 2, we knew we wanted to focus on art since this could better reflect the create and share aspects of the RIX framework. We landed on texturing since this works as an action within our digital world, is another great game development topic to explore, and imbues interactivity within the story of the chapter. We utilized hex codes as a fusion of art and technology within the texture editor. Players can change the colors of the textures by using these hex codes. This fusion is reinforced by having players enter the code manually instead of just displaying it. In this way, we use interaction to show that art can be represented in a programmatic fashion and further push that Steam connection. With chapter 2, the focus shifted from linear puzzle solving into one of more customization and creation. In order to keep the player connected with our goals, we utilized Brad as more of an encouraging guide who responds to Alistair's questions and observations. Next, Jamie will dive into more of the programming within chapter 2.
Thank you, Lawrence. In chapter 2, we add a new feature submenu to the inventory system. When players click on a pattern, it will show the submenu with 5 copies of this pattern. Players can save different color strategies on this copies for later texturing. To edit the pattern, texture merge shader was used by the preview area of the texture editor. It loads in color 1 and 2 and shows what the pattern will look like when players adjust the colors in runtime. There's a color placed in front of the preview area to capture the edited pattern as a render target when save button is pressed. This render target will be passed to a distort shader to texture an object in the outside world. Distort shader is implemented to texture 2D images of a 3D space and fake the 3D look and feel. It has 3 main functions to simulate the viewing angle of an object: rotation, distortion, and density adjustment. You can see in the middle that the texture aligns with edges after rotation, and then after applying density adjustment, the part of the texture which is more distant from the player gets denser. After doing all this, it overlays the result with the original object sprite to keep shadow information. This is another example when apply distort shader on the ground. On the left, the picture shows the original texture without shader used. After distorting along x-axis, it has a look on the right. And then we adjust density along y-axis of the texture and get the final result. After playtesting chapter 2, we realized that more patterns are needed to better reflect the natural and outside world. So we finally chose A to B gradient pattern. The picture on the right shows the outside world after applying it on the sky and tree. And now I'll hand over to Sally to talk about art.
Thank you, Jamie. We were building a point-and-click adventure wherein the scene served as a user interface. We wanted to design a gallery space that was abstract and visually compelling. So we drew inspiration from modern art gallery images for the structural design and lighting. The models had a mix of solid and emissive textures. The walls were high fidelity to act as contrast to the canvases and also draw the user's attention towards the interiors. Volumetric fog, mesh lights, spotlights, and area lights were used to achieve realistic interior lighting and indirectly navigate the user's eye. We visualized this texture editor as a basic medium that facilitated create and share. So we lay our design of a blocky sci-fi hand with colors flowing down into an RGB pool. Coming to the outside world, it was custom modeled to be set in a corrupted digital backseat layer. So the mountains were inspired by digital signals, the clouds represented data clouds, the floating bit trees inspired by code blocks in chapter 1, and the rocks were modeled as message icons since chat was an important aspect of our experience. And lastly, location, a repeated motif in the inanimate Alice episodes, was embedded as a natural element. The environment was textureless, affected by the data transfer, so only the gallery was textured by reusing the textures from the gallery interior. A combination of directional lights was used to keep the lighting consistent between the gallery interior and this outside world. Area lights and spotlights were used to further distinguish the gallery from the textureless environment. Sherry will now talk about the changes that we made after softs.
Thank you, Sally. So we received a lot of valuable feedback from soft, and we mainly focused on 2 of them. The problem got most often mentioned is that in chapter 2, we didn't provide our players with enough instruction. Hints were mostly stated in the chat with Brad and Alice's monologues. So if our players missed it, it would be hard for them to follow through. Also, as Jamie mentioned before, we added a submenu for more variants of the textures. This might sound like a good idea on paper, but in fact, it introduced a new different interaction pattern that we never taught our players in the previous chapter, which made our players more confused in-game. So to solve this problem, we used the hint system in chapter 1 and added general hints throughout the scene. If our players get lost in the game, they can always hover their cursor on the question mark and get a brief hint on what their current goal is. By implementing more hints and instruction in this manner, we were able to remove the restriction put on certain features which hindered our players' freedom. We also removed the submenu for the textures and went back to the easy and intuitive drag and drop interaction in consistency with the previous chapter. Another topic that got brought up several times during soft meetings is visual clarity. In this screenshot, chat bubbles blended into the background because of the similar turquoise color, and the edges of the corrupted light blue chat bubble was also distracting. So we revised the chat UI a little bit. Now it's easier to tell who's speaking because of the profile photos of Alice and Brad and the new chat bubbles with offsets. We also added a half-transparent background to make the chat content stand out more. Another place where visuals cause confusion is the color UI in the texture editor. The gray mask on the unselected color might cause a color perception bias. Therefore, we get rid of the gray mask and use a highlighting border to tell the players which color is being modified. Last but not least, we increased the line spacing and eliminated the text orphan throughout the whole experience so as to make it more visually pleasing. Next, Rongjia will talk about our summative playtest results.
Thanks, Sherry. For summative playtest, we ended up getting 14 responses. You can see the curve mostly skewed to the left with a decrease in perceived programming difficulty by 8%. Also, this group had a 9.7 increase in interest in programming, which would correlate to 487 middle school students in Pittsburgh. Here are some feedback we received. Students indicated that the changes made our experience more fluid. They also liked the glitching effect in chapter 1. We've learned a lot through this project. First of all, since there's a lot of ambiguity in the original episodes, we aim to appreciate how ambiguity can spark further conversations. Weakness, however, can also turn into a lack of explanation. Also, we probably should have done more synchronous playtests to gather real-time reactions and thought process, which is greatly hindered by the limitations of COVID-19. A design lesson we have learned was that sometimes things that sounded good on paper didn't actually work, like the submenu Sherry just mentioned. In terms of documentation, we have written a development journal, which outlines our process and serves as an educational reference. Here's our client testimonial.
It goes beyond bringing us closer to the goals. I think it helped us clarify our goals. We learned things that we didn't know that we needed to know.
For me, it's allowed me to see the possibilities of digital narrative in STEM education, but always the questions looped back to the pedagogical implications, how this work could be used effectively in the classroom, how it could help us meet our goals of preparing teachers to use Alice in the classroom. And it helped me clarify my thinking a lot about what the curriculum should look like.
We were in the transition phase between looking at our literacy objectives and moving towards a STEM pathway. And this particular project's given us a lot of opportunity to talk in detail about those STEM objectives and how we can head off in that direction. So it has actually provided that shift for us. It's a good fit for what we were aiming to do anyway. It just takes us and adds a tangent, it adds depth to what we're doing.
Our client plans to use our deliverables for an NSF grant and a Games for Change submission. Special thanks to all these teachers, playtesters, and faculty members, especially John Baylash, who has been providing feedback and facilitating playtesters for us. We are teamed Interactive Academy, and we are now open for questions.
All right, great job, team. Congratulations. So if anybody has questions, jump right in there and chat or speak up.
Go ahead, Mike.
Yeah, I have a question on your scene 2, and I'm curious whether your playtesters thought it was expressive enough to really make beautiful pictures. Do you either have an example of something beautiful that was made and shared that people were really proud of? Or can you talk about that? Was it a scene you can really compose something beautiful on top of?
So we had a couple playtesters that did take a bunch of screenshots of a variety of different scenes. For instance, during festival, my brother really got into chapter 2 and spent probably 15 minutes, if not more, like making sure to compose the perfect scene and really playing with the hex codes, playing with color balance to create a scene. He's a little older than our target demographic, but I think that just shows how much he was able to enjoy it as well.
Yeah, if you saved a screenshot, throw it in your blog. I'm curious to look at it.
Definitely.
Yeah. Also, in our summative playtest, we asked a question about how many screenshots that students take, and I think we got our answers range from like 1 screenshot to 6. So if that's equals that.
I got a question. So you guys are making effectively an adventure, a point-and-click adventure game. Any insights into the general playtesting of that? I mean, you mentioned that hard to get the balance between like hints and intentional confusion, right? Did you discover any strategies to like see that or understand that better?
So we were trying to ride the line between a point-and-click adventure game in more of the traditional sense and just going for more of a highly interactive experience that used point-and-click mechanics. And I know for me, I learned a great deal about point-and-click adventure games, and as simple as they are on the outside, there's a lot more complexity behind the scenes that goes into that. I think learning more about some of the minutia of point and click design could have helped us maybe alleviate some of the ambiguity we found out early on, or later on, I mean.
Time for one more.
Not a question, but a request. I see the link to your build, but I can't get to it. Can you put that link in your chat, in the chat, please?
Yes. Ranja or Jamie, could you put the link?
And thank you, Shirley, for pointing out that word choice mistake. I'll definitely correct this.
Yeah, so our build is hosted on both the ETC server and our client server. I think the ETC server is going to go away this semester, but it's going to be on the client server. And there's going to be Google Analytics that is going to be embedded. So there's going to be some meaningful data tracking even after we end this project.
All right, congratulations, team. Good job on your finals. So you can turn your cameras off. We'll unspotlight you, and if cloudworks can turn their cameras on, we'll get them going.
Can I do a quick mic check? Can you guys hear me?
Yes.
Cool, thank you.
Getting there. That's all of you all, right? Now, who am I missing? I'm missing somebody.
Annie.
Sorry, Annie. There she is. Sorry. Ta-da! Whenever you're ready.
Hello. Okay. Let me make sure I'm doing. Okay. You can see my screen. Okay. All right. So good afternoon. We are Cloudworks, and our project for this semester was to design, create, and host the first ever ETC virtual festival that took place just this last week on Saturday, December 12th. So this is our project team, and our advisors for the semester were Shirley and Dave. In order to summarize everything that we delivered for the festival, we can distill it down into 5 major elements. The first is an MMO-style virtual space, and this portion of the festival was invitation only and allowed attendees to walk and talk with one another, experience student work firsthand across 3 different sessions. The next is 2 live streams of the festival, which were scheduled showcases of all the work that was featured within the virtual space, and these were publicly viewable for anyone who was unable to join us in the world. And the final obvious element that we delivered was the public-facing website. So this is both a repository of student content and also the access point for the festival world itself. The 2 less obvious parts of the festival include both the manual seen here and the catalog, which were shared resources that we provided to the guests for use during the event to make it go smoother for them. So to recap some of the metrics that we saw from Saturday, we had 450 RSVPs, an average of 100 concurrent guests through each session of the virtual space, and over 1,000 views on each of the live stream sessions. Early on in the project, research and playtests helped us to focus on 3 primary design goals. So supporting live project work and providing a good guest experience were large goals for us to target because they allowed us to directly connect back to the original festival. However, the less obvious and perhaps more important target for us was a feeling of camaraderie and community emergent from the experience. The festival's a tradition for the ETC, and it's a time in which we gather together and celebrate the work that's been done, meet with old friends, and make new ones. And from a community perspective, 2020 has been an incredibly difficult year, especially for the first-year students being the very first remote class. And so cultivating a sense of camaraderie and connection is really the secret, true reason that we are maintaining this tradition. So now I'm going to pass it over to Annie, and she's going to talk about how we've started to tackle our design challenges.
Thank you, Jack.
So when designing a virtual festival, we faced four main challenges. In the traditional festivals, tech was less of an issue, but for a virtual festival, if the tech went down, our whole project goes down with it. Because this was something that nobody has done before, we simply did not know what would actually work. We did a lot of testing to help us find the most robust solutions. Then we moved on to bigger and bigger playtests in order to discover which features were actually needed and to help us iterate customized frameworks to facilitate guest-student interactions. So, how did we make design decisions for cloudworks? It seems a little bit overwhelming, and it kind of was. All these factors shaped our designs, but for now, we'll focus on how our playtest pushed us on iterations. We had weekly playtests and worked closely with the BVW class and the whole ETC community. We also provided consultations for BVW students on how they could design for the festival experience. Because we were faced with so many uncertainties, we relied on playtesting to bring clarity to the unknown. From an early stress test, we realized that we must iterate our server design, which forced us to redesign everything. As you can see, we changed our entire environment and added a personal local hub to adapt. As we got closer to the feature lock, we follow up with more playtests to check the robustness and user-friendliness of the iterated design. So here are some changes we made from playtesting. In the last week, we added in the much requested direct call feature. This allows the guest to call one selected guest while moving around the space. And we added a microphone icon to show if someone was on call actively speaking. You can mute yourself or disconnect whenever you want. We also learned from the playtest that there was a learning curve for the guests to learn about this platform. On the last few playtests, we were overwhelmed by tech support needs, so we added in an interactive tutorial in the virtual space, where you can learn about the basic movement, interactions, and how to engage with the students' work. Furthermore, we also provided onboarding supports on our website, as well as a printable menu, as you can see on the left, for guests to print it out and have it handy during the experience. On the day of the event, our tech support Zoom room was surprisingly quiet. From the feedback survey, guests have responded finding these onboarding support mostly helpful. One last but not least biggest challenges we faced was not being able to have a Mac build within our time and tech constraints. As an alternative, we created a festival catalog. On this catalog, it allows the guests to access all the project information, including directly downloading the games and entering the team's Zoom call to play with other guests simultaneously. It was not ideal, but it was the most robust solution we could provide in this short amount of time. And next, Kara will talk about cloudworks art and theming.
Thanks, Annie. So in order to create the sense of belongings, we designed the avatar pipeline for guests to create their own avatar. First, people need to submit their concept art, then use the guideline and template we provided to make it pixelated. Here is the final result we got from ETC students, faculties, and outside guests. After receiving these avatar sprites, we implemented to our system, which allows guests to apply different colors on it, and this brings more diversity to our avatar. As we mentioned before, we separated the whole festival into 4 different areas: BVW Carnival, Sunside, and Sunrise, Visual Story Theater, and Project Park. In the BVW area, we provided both inside and outside template for the first-year student to use. They can decorate their rooms like what they will do in real ETC building. We also added a cloudworks museum in BVW Sunset area to show all of our prototypes and works we've done. In the Visual Story Theater, we put 3 TVs to let guests watch first-year Visual Story team's amazing videos and leave comments. For projects, thanks for all the projects' help for providing their statues. We put them into our park, and guests can enter in each team's Zoom by clicking on their statues. For theming, we use a little UFO as guest's personal hub, as well as the exit of 4 areas to create consistency. As you've seen before, the 2D pixelated character sprites and the 3D voxel environment model also help a lot with keeping cohesiveness. Furthermore, we follow the color palette we set at the very beginning of this semester, which also unifying our environment and avatar as a whole. Although the cutscenes we put in the beginning of our experience leads people transit from the real world to our virtual world smoothly. Next, I will hand over to Alan to talk about the tech part.
Yeah, thanks, Kara. Now I'm going to talk about what programmers have created for the ETC online festival. Imagining an ETC festival with absolutely no social experience, that will be terrible. Thus, our team first built the multiplayer system as the foundation of the whole festival experience. We chose an open source Unity multiplayer framework called Mirror as the foundation of our online system. And with some optimization and parallelism, we were able to host 720 guests at the same time. After we implement the multiplayer system, we realized that the voice chat system is necessary for the guests to communicate with each other. At first, we tried to implement voice chat systems by ourselves, but it seems that developing such a robust voice chat system is much harder than we expected. Since robustness is quite important for our festival experience, we chose to use the Photon Voice plugin, which is both robust and simple to use. Voice broadcast system was implemented after the voice chat system. At first, we thought we could just use the Photon Voice plugin to do that. Actually, we couldn't because of the maximum user limitation of the plugin. That plugin could not handle 500 guests or more. After conducting a lot of research, we chose to use Icecast, an open source web radio technology, to do the voice broadcasting work. We also wrote an easy-to-use tool program so that our non-programmer teammates can easily broadcast their voices. The next system we implemented is the avatar system along with the avatar pipeline. Given the art assets generated from our pipeline, our implemented avatar system is highly efficient and our artists can easily import new avatars. One huge task we need to do was importing all the rooms and tents created by our friendly BVW students. It was much more challenging than we expected because BVW students sometimes made changes after they submitted. Fortunately, all the BVW rooms met their creators' expectations in the end. There are many other systems we implemented, such as invite code system, ISVP email system, festival website. They are also important for the whole online festival experience and should never be ignored.
Thanks, Alan. Now, after Alan explained the what, let's take a look at the hows. I would like to share some tips that we learned along the journey. So first, a good design can always lower the complexity. For example, the personal room is one of our best design. It looks like the personal room mainly serves as the start point of the whole experience. But what's more, the personal room is actually the key piece to our network system. Why is that? So right after mid, when we still have the idea to squeeze everyone into one world, the strat tests tell us that no, you guys cannot do that. One unified server cannot host every guest. So we distribute the content along several servers and the personal room idea justify it. It serves as the bridge on your own machine and reach out to the other network servers that provide the festival content. And later on, we also surprisingly find that it also makes our life much easier to attach additional network services. And the other tip is to iterate based on the feedbacks. So as a discovery project, sometimes we just have too many ideas to explore. Besides, as a deliverable project, we are worried about the robustness. But luckily, as Annie mentioned before, we have playtests every week, and from those playtests, we collect feedbacks. For example, direct bug feedbacks. Every week, a huge bug list will be compiled, which will keep like the tag guys, especially nervous for some days, but we are still very thankful to those lists because we will never be able to discover all of those bugs on our own. The other kind of feedback is the design feedback. So we sometimes call it the wish list. When setting the goals for tag iterations, we will compare the wish list with our existing code base to prioritize things. Following that pattern, we can always make sure that our new features are on the right track and we are not out of scope. And the last thing I want to mention is just working hard. Real life is nothing like the movies where the main character becomes stronger after some montage with heroic BGM. We always have to pay the efforts and pay more if the objective is crazy. And next, I will hand over back to talk about our overall learnings and reflections.
Thanks, Jim. So after the festival, we sent out a feedback form to all of our guests to learn more and be able to say if we reached our project goals of guest-oriented, project-oriented, and camaraderie. Here's a clip of our guests interacting with student work and having a blast. Based off of our feedback, our guests found it was easy to engage with student work, and experiencing it was most of their favorite moments. We were able to create fun and surprising moments for guests of all ages and levels, from Anthony Daniels to Hazel Silva, and we believe this all is evidence of us reaching our goals of being guest and project-oriented. We believe we were truly able to foster a sense of ETC camaraderie, especially among the first years, most of whom had never met in person before. Their effort and their ownership of the festival show success for our final project goal. Shown here is perhaps my favorite evidence, a compilation of virtual team photos, Zoom rooms, and more taken after the festival had ended. Many ETC students, unprompted by the cloudworks team, decided to stay longer in the virtual world to experience each other's work, celebrate, and bond as classmates. But perhaps the greatest success our team can take away from this project is the opportunity to learn as much as we did. If we were to make another iteration, these would be the first things we would love to take another crack at. We created a BBW room template, pipeline, and merge tool, but adding in the BBW rooms still took us more time than we expected. Importing one BBW room would take us more than about half an hour, and with students iterating on their rooms, we did this several times per team. We could not implement the rooms earlier due to jury, but now that we have the merge tool, we can design a better pipeline, and room implementation will be much easier and quicker. We decided early to focus on a robust Windows build, yet we were hopeful that we could add a Mac build. However, with other huge features taking longer than expected, we were not able to. For us to make a Mac build, we needed a fully locked feature set to branch off of and change the many features that were reliant on Windows system calls. Unfortunately, we did not have that locked feature set until 10 p.m. the night before festival. But now we know to commit to both early and to take on an additional programmer to help with the workload. As for the timeline, we know so much more now as opposed to the beginning of the semester when we weren't even sure all of the choices available, let alone what the right choice was. Luckily, our educated guesses weren't too far off, but if we were able to shift everything a week earlier or even shift the festival itself a week later, especially since some courses were still finalizing their syllabus well past halves, our timeline would be much more comfortable. And communication is an area we definitely could have improved in as well. For example, a lot of the show-stopping bugs listed in the feedback we had already found a fix for. For example, resizing the application screen to fix the hidden chat UI bug. But unfortunately, we did not communicate that well enough, but now we know to do better in the future. And now I will pass it off to Jack, who will finish us off.
Thanks so much, Beck. So before we finish up, we do just have to extend our heartfelt thanks to all of those who helped us to get to where we are with the festival, to all of our playtesters and consultants along the way, as well as all of the ETC students who volunteered their own time to provide us assets to really bring the festival to life. Thank you so much. And with that said, we are cloudworks, and we hope that you enjoyed the ETC Virtual Festival 2020. And we're now open for questions.
All right, great job, team. Congratulations. So Chris has a question, and then anybody else throw them in chat, and Dave will help.
So I think you did an amazing amount of work. It's an astonishing achievement. Why didn't you decide that you were going to deliver the experience through a browser, which would have been cross-platform from the beginning?
I think that can be categorized into a tech problem. So at first we are planning to put this one onto the website, but there are several problems, and we iterate the idea with Dave a lot of time. So for example, BBW World, the biggest part of the festival is experiencing BBW World, but lots of BBW World, they are not only with Air Console as the platform. So we have to support those like wonderful multiplayer games, and they are PC only. And yes, and for the Mac, they will, it's the same problem. It's like we will have to like ask them also to have the Mac build to like include in our Mac build. Yes, this is an extra one. So, and also besides that, I think a lot of like audio broadcast and audio chat stuff, they request specific web browser privilege to access those devices. So it's just an extra workload, and we are not very sure that we can achieve those on time.
A lot of plugins we chose to use were not supported by the web browsers because we discussed with it like either we want to go with a limited version of festival on the website, or do we want to aim for like a full complete features for a Windows build. And we like this is a big decision, so it took us like about 2 or 3 weeks to make the final decisions to decided to go with a Windows build that not limit the BVW students' work. Because if we were to go with WebGL, we would have to limit a lot of students' choice on their work to make it compatible to the website browser.
Thank you.
Thank you.
So I have a question. My question will make Steve nervous. So Steve will come after me. My question is, should future ETC semesters always end in a virtual festival to share with the broader community? And if so, how much prep time would it take a couple work study students to get ready for a project only semester in spring and for projects plus BVW in fall?
So that's a great question. And, you know, something that we had thought about a little bit of like, how would this look in the future? Especially if there is an opportunity to have an in-person festival in the future, I think that is bar to none is having that in-person experience. However, I think having this sort of virtual festival is an awesome supplement, especially for people who don't live in Pittsburgh and can't always make the festival. Like we had students who have family members who live in other countries and wouldn't have gotten a chance to experience the festival otherwise. So even if we do have an in-person festival, we think it would be nice to have some sort of virtual festival added on in addition to for everyone who isn't able to make it.
How much time to prepare? Hundreds of hours? Thousands of hours?
I'm not entirely sure the amount of hours, but luckily for you all, we all have a great code base already to begin with. And if you would like to hire us as your work study students, please do.
I would say if it would take at least a semester student project, a heavy load semester project.
Especially in fall semesters when you have to coordinate not just with semester-long projects, but also BVW and Visual Story. Just because, I mean, it was especially difficult being remote just because I think everything takes a little bit longer coordinating, but getting all of the pieces that we needed, it takes quite a while. So even with the framework set up, it takes time.
Steve, question?
Hey guys, good job. I wanted, and if you mentioned this and I missed it, I apologize, but I assume that you have some sort of anecdotes or some sort of list, some sort of handoff to a potential future team that does this. Was that written up formally, or like I know you guys have thoughts about how to do all the things you couldn't do if you had more time? And
yes.
And then given that, like, would you do it the same way and all those things?
Yes, so we do have documentation that we are currently working on. Sorry, I keep looking at your video and I should look at the camera. That we will have available by Friday of all the documentation of all of our tech resources, all of our design learnings, etc.
All right, that's time. Oh, go ahead, Beck. You can finish.
No, I was just going to add on that, and that'll have a lot of our learnings as well, because we learned so much, and we only touched on a little bit of it in this presentation, but we could fill up another hour of just things we learned.
Oh, there was never a doubt that you guys wouldn't learn a ton trying to do this.
All right.
Fortunately, it worked out.
Well, congratulations, CloudWorks. Congratulations to all of you for completing your final presentations. Great job. Really good job, all the students. So everybody enjoy the rest of your day as you get ready to head off into the holidays. And faculty will see you all in grading.
Good job, everybody.